Familiar. I've seen this. I've worked with somebody else that used this. Okay, tell me where we need to go.
So we're doing 7 through 14, I believe.
Which lesson?
4-11.
Okay. Well, first of all, let me read the problem. All right. So let's do what they suggested. Let me take a picture of this. Always follow their hints. So how do we graph that right there?
Do you go down
First of all,
to
what kind of graph is it? What's it called?
a vertex?
It's called a parabola.
A parabola, I mean.
But you're right, this parabola is in vertex format. So where is the vertex?
Will it be at the -2?
That'd be, here's the standard format of the vertex. Let me write that. Once you know the standard format, then you can always figure out the other stuff. Here's the standard format, vertex format, for a quadratic or a parabola. Okay? Now, look at that and tell me, what's A?
A is X. A is nothing.
A is 1. It's not nothing. 1. There's a huge difference between 1 and 0.
Yeah.
Okay, so A is 1. What is H?
2 or -2.
Well, which is it?
-2.
If I look at that equation right there, or that expression, x minus h, and that is the same as x minus 2, correct?
Yeah.
So what is h?
2.
Correct. Positive 2. Very important you get the signs right. And what is k?
-3.
That tells us where our vertex is. Okay,
yeah.
And that's the, so if I go to 2, let's see, each one of these is 2. So that's 2, -3 right there.
Yeah.
Does this thing open up or down?
Down.
It depends on the sign of A. If A is positive, it opens up. If A is negative, it opens down.
Yeah.
So which way does this open? What is A?
1.
Positive 1.
Positive 1. So will it go up then?
So it opens up, exactly. Now, if I were to graph this, I really kind of need a second point. Let me again read the directions. You need 3 points to graph a parabola, and we only have 1.
Yeah.
And I know it either opens up, but I don't know if it's skinny or fat. So I need two other points. Now, I can solve for the X intercepts, which is the usual points they want. Even that, this is going to be tough to do graphically. Let's go ahead and take a shot at it. Okay.
Yeah.
The X intercepts are where y equals 0. Okay. So if I set 0 equal to x minus 2 quantity squared minus 3, move the 3 to the other side. Tell me if I lose you. Take the square root of both sides. And finally, add 2 to both sides. There are your two x-intercepts. Okay, if I take square root of 3 is about 1.7. So if I take 2 plus 1.7, that's 3.7, which is about right there. And if I take 2 minus 1.7, I get 0.3. If that's 1, that's about 0.3. So those are my two x-intercepts. And now I can draw my parabola as best as I can figure out how to draw it. So there's my parabola, okay?
Yeah.
And now they said also graph y equals plus 1 on the same set of axes. Well, what does that look like? What does y equal plus 1 look like?
Y equals plus 1.
Is it a vertical line or a horizontal line?
It'll be vertical.
No, horizontal. It's y equals 1.
Oh, so okay, so it's going across.
Well, those are the y values. In other words, notice where it crosses the y-axis at 1. In other words, the coordinates of that are 0, 1. So no matter what x is, y is 1.
Yeah.
That's why it's called y equal 1, and that's why it's a horizontal line. Now, they want us to solve this problem using these points of intersection. Whenever you're solving equations graphically, that's what you do, is wherever they're intersecting, that is the solution. Well, what do you think this first solution is? On the left circle. Where does that look like it is? What is the coordinates of that?
0 and 1.
Yeah. Okay, so one solution would be x equals 0, y equal 1. And this other solution, it's hard to see, but not that hard. Where do you think that might be?
X equals. Is that on the 2?
Each grid is 2.
Oh, so is that 4?
That's what I would say. And y is equal to 1 still.
Yeah.
Whereas no matter what x is equal to, y is going to be equal to 1. So we think that is the solution. In other words, this point would be 0, 1, and this point would be 4, 1. And now it says use algebraic strategies to solve the equation and verify that your graphical solutions are correct. Okay?
Yeah.
I'm going to get rid of everything but the solutions. Now, how do I solve this thing algebraically?
Are you going to rewrite it?
Well, you got two equations and two unknowns. Here's our first equation. Here's our second equation. When you have a system of equations, you can solve it by substitution, you can solve it by elimination. Or you can solve it graphically. We solved it graphically. We came up with a solution, but it's hard to solve things graphically because you have to interpret a grid and we may not be on exactly 4 there. We won't know. So algebraic is the only thing that's going to give you the exact answer.
Yeah.
I'm going to use substitution or elimination here.
Should we do substitution?
Okay. So what should I write?
So 1.
Perfect.
1 equals, and then
everything that I have up there.
1 equals x minus 2 squared minus 2.
Yeah. In other words, both of these things are equal to y. If they're both equal to y, then they're equal to one another. But really, the way to think about it is you're substituting this y value, y equal 1, into the first equation. So you get 1 equals. The last time we did it, when we were looking for x intercepts, we used y of 0 because that's what the y values are when you're on the x intercepts. But when you are looking for intersection points with the line y equal 1, then you're going to substitute 1 for y. Now solve that.
Wait, do we put the x value in?
Nope. You got a single equation now with only one variable. You can solve that.
So
whenever you have one equation and one variable, I don't care how complicated it is, you're going to be able to solve it. Know that.
Yeah.
It's when you have two variables and only one equation that you can't solve it. But if you have two equations and two variables, you can solve it. But when you get it down to one equation and one variable, you know you can solve it. So what do we have to do to solve this?
Do we add 3 to get rid of the negative 3?
Good. That's a good first step. Remember, our goal is to always isolate the x. Our final answer is x equals something.
Do we have to square the x minus 2 squared? Or
square root.
Square root of?
Square root. Yeah, if you take not just the x minus 2, but both sides of the equation. In other words, you can't just take the square root of the right side of the equation without taking the square root of the left side.
Yeah.
So after you take the square root of both sides, what do you have?
2 equals?
Actually, plus or minus 2.
Oh, yeah.
When you are solving, I'll say it one more time. When you are solving an equation and you're doing it by square roots, always, always begin your answer with the words plus or minus. There are no exceptions. If I'm
Yeah.
solving an equation by taking the square root of both sides, my answer begins plus or minus. And what's it equal to?
X.
No? What's the square root of that thing right there? It's x minus 2.
Okay.
In other words, it's whatever was being squared.
Yeah.
If I had something over here, x cubed minus x plus 17, and I was squaring that, and then I said, well, take the square root of that, what's the answer?
X cubed minus x plus 17.
Okay. So let's keep going. We're not quite done yet. We haven't isolated x. What do I have to do to isolate x?
Subtract or add 2.
Okay, so I have now 2 plus or minus 2 equals x. So there's my x value. Actually, there's two answers there. What are they? X equal what?
X equals negative.
No, the first answer is when you use the plus. The second answer is when you use the minus. So what's the first answer? First answer is you use the plus.
So 2 plus negative 2?
First answer, you use just the plus.
So just 2 plus 2?
Second answer, you use just the minus.
So 0?
Now, if x equal 4, we know y is equal to 1. Y is equal to 1 no matter what x is equal to. And when x equals 0, y is equal to 1. So algebraically, we just showed that the two solutions are 4, 1, that one, and 0, 1, that one. So our algebraic solution verified our graphical solution.
Yeah.
And that's what they want you to do here. Now, do we need to fill out anything here to progress, or is this just for review purposes, or?
No, that's all she wanted.
Okay, so we don't have to fill out anything?
No.
All right. And are we scrolling down? Oh, we're going to back up and go to 4.8, right?
Yeah.
Oh my goodness. Think about rewriting, looking inside, or undoing. Oh, I hate it when they use terms that I am not familiar with. I know how to do these problems, though, and that's what's important. Now, let's look at A. Are you familiar with solving by taking the square root of both sides?
Yeah.
Yeah, we just did it.
Uh-huh.
That's how we just solved that last problem, is we took the square root of both sides.
Yeah.
Let's solve this one by doing that. And you might say, well, how do I know that's the proper technique to use? Well, it's because all of the x's are wrapped up into that right there.
Yeah.
True that I'm going to have an x squared and an x term, and I could just expand this whole thing, convert it to a quadratic, and factor it and solve it that way. But I guarantee you that if you can solve it by square root of both sides, it'll be much quicker, faster, easier.
Yeah.
So, what's the first step?
Subtract the 7.
Second step.
Do we square root both sides?
Not yet. You can't square root both sides until you've got everything that's being squared isolated. Well, this leading 2 here, that's not being squared.
Okay.
Only what's inside the parentheses is being squared. So I got to get rid of that 2 before I can take the square root of both sides.
Okay. So subtract the 2 then?
Not subtract. What is that 2 doing right now?
Oh, divide the 2?
Correct. In other words, that 2 is a multiplier at the moment.
Yeah.
When you want to get rid of multipliers, you divide. If you want to get rid of dividers, you multiply. If you want to get rid of stuff being added, you subtract. If you want to get rid of stuff being subtracted, you add. You always do the inverse of what you're trying to get rid of. So we're going to divide both sides by 2. What's the next line?
X minus 1 squared equals 16.
And now what?
So now you square to get the square root of both sides.
Okay, and what's the next line?
X minus 1 equals 4.
Remember when I said whenever you're solving an equation by taking the square root of both sides, what's your answer got to begin with? What words?
Plus minus 4.
Uh-huh. Now, do you realize why that's true? In other words,
yeah.
minus 4 times minus 4 is plus 16.
Yeah.
And plus 4 times plus 4 is plus 16. So it
yes.
really does indeed have 2 answers. Okay. Now what?
So now do you
try and isolate X. What is still keeping me from isolating X?
-1.
Okay, so what do I got to do?
Add 1.
Okay. I'm going to put it in front just because that's a more familiar place for it to be. Now tell me the 2 answers.
So X equals I'm kind of confused on how to get the final answer in this part.
First answer, use the plus sign only.
Oh, so 5? And -3?
There you go. A lot of people see this their whole high school career, and they don't know that how you get 2 answers out of that.
Yeah.
That's how you do it.
All right.
Just use plus for one answer and the minus for the other. Now, if we wanted to, we could check, does 5 work? Well, 5 minus 1 is 4. 4 squared is 16. 2 times 16 is 32, plus 7 is 39. Does work. Does -3 work? -3 minus 1 is -4. -4 squared is plus 16. Times 2 is 32, plus 7 is 39. So both answers work. And when you're solving polynomials like this, both answers will almost always work. But when you have radical signs like that one, sometimes one of the answers doesn't work. It's called an extraneous solution, and you have to throw it out. So let's tackle that problem.
Okay.
By all means. That's the next one we should look at. Now, remember the goal is to get a final answer of m equals something.
Yeah.
So we got to get rid of stuff. What's the first thing to get rid of?
The 7?
Correct. Not the -3. And the reason is the -3 is actually being multiplied by that 7.
Yeah.
So we can't get rid of it yet. So I'm going to get rid of the 7 by dividing both sides by 7. Okay. Now what?
Now do you get rid of the 3?
Correct. What's the next line?
So then it's the square root of n plus 1 equals 6?
Next line. How do I get rid of this radical sign?
Do you square it?
Yes. You square both sides. You square the left, I got to square the right. Now when I square the left, what am I left with?
M plus 1 squared?
Just m plus 1.
Okay.
In other words, I started, when I got the square root of x, and I square it, that's equal to x.
Yep.
No matter what x is, always. Square root of 17 squared is 17.
Okay.
Okay, so that's equal to 36, which is 6 squared. And so
Yep.
m equals 35. Is there any plus or minus needed here?
No.
Correct, because never once did we take the square root of both sides.
Yep.
We were only squaring. And when you square this, it comes out m plus 1. There's no plus or minus. When you square 6, it comes out 36. There's no plus or minus. Now, let's check that solution. If we plug it into the original equation, we got let's see if that's correct. Square root of 36 is 6. Incidentally, when I write it like that, that's always just plus 6.
Yep.
Do not confuse that to solving an equation by taking the square root of both sides. When I write square root of 36, that's 6. If I want the negative, I write it like this. That is minus 6.
Yep.
Okay? So, that works. 7 times 6 is 42. Minus 3 is 39. What's going on here? One moment. All right, let's see. Divided by 7. That made it 3. And then we added 3. That made it 6. And then we squared both sides. So we had m plus 1 equals 36. That means m is 35. Now is 7 times the square root of 35 plus 1 minus 3 equal to 21. Yeah, it is. The first time I did this, I didn't include parentheses around that. And that's why I got screwed up. When I include parentheses, like are in the problem, or the parentheses, then you get actually 7 times 6 minus 3, which is 7 times 3, 21.
Yep.
That indeed is the correct solution. In addition to showing you how important parentheses are. Notice when I did it the first time, I left out the parentheses and I didn't get it to work.
Yeah.
All right. Let's look at B. Now, or C, excuse me. Automatically, when you see equations that have fractions, they are more intimidating, correct?
Yeah.
So what if we could get rid of all fractions in one fell swoop? What can I multiply both sides by?
2?
Well, that'll get rid of that 2, but it won't get rid of that 3, and it won't get rid of the 6.
Would it be 3 then?
That'll get rid of the 3, but it won't get rid of the 2, and it won't get rid of the 6. Last shot. You got one more guess.
0?
6.
Oh, 6.
In other words, if I multiply the left side of the equation by 6, in other words, it's basically the same as finding a least common denominator. Okay. Notice I'm going to multiply that 6 by that first term. What have I got? What is 6 times x over 2?
6x over 12?
No, you only multiply numerators. You don't multiply both the denominator and the numerator. It's 6x over 2, which is the same as what?
3x.
Okay. Got rid of that denominator. What's the next term? What's 6 times x over 3? In other words, I'm doing that, which I just did. And now I'm going to do that.
2x.
Okay. Now, over here, what do you got?
2.
Don't multiply it out. Cancel first.
Okay.
What's left?
5x plus 2.
They really do that to us? You couldn't possibly have done that to us. Notice that this has no solution.
Yeah.
Because this is going to turn into 5x over here. I'm going to take away 5x from both sides, and I'm going to have 2 equals 0. Well, 2 can't be equal to 0. So, let me go back, figure out what I did wrong. I multiplied the left side by 6, which gave me 3x plus 2x. Multiplied the right side by 6, gave me 5x plus 2. No solution. Sometimes they'll give you a problem that just has no solution. I'm curious to see what their hint is. I'm gonna open that hint. Well, that's not terribly helpful. I got to think they made a mistake here. They didn't really mean to give us a problem that had no solution. Even though the second part of the help suggests that we don't have a reasonable solution. I guess that's what you could call no solution, is not a reasonable one. It's hard to test a solution to see if it's reasonable if you can't come up with it, and we can't come up with it. When you get 2 equals 0, you're dead in the water. All right, let's go to number D. Again with the fractions. Now, what's one thing I could do?
Could you add 7?
Yeah, there's actually 3 different ways to do this problem. That's not a bad way to start. Now what? Trying to isolate x. Always keep that as your goal.
Divided by 2?
It's currently being divided by 2. You always got to do the opposite.
Oh, multiply by 2?
Okay. I multiply by 2, gets rid of that 2, turns that into 30. Okay, now what?
Is it 8x plus 4 on the left side?
No. When I multiplied it by 2, all it did was get rid of that denominator. That's why I multiplied it by 2.
Yeah.
In other words, I multiplied it by 2, but that 2 canceled with that 2.
All right, yeah.
Leaving me with 4x plus 2. So here's where I'm at. 4x plus 2 equals 30.
So subtract 2.
4x equals 28.
And then divided by 4 on each side.
There's your answer. Now, before we go on, let's examine a different way to do this problem. Notice that the biggest problem is that denominator, right? I could just multiply everything by 2. I like that solution because you immediately get rid of all denominators.
Yeah.
What do I have on the left side now? You got to be able to do this algebra is the thing.
14.
No, it's minus 14.
Minus 14 plus 4x plus 2.
What do you have on the right?
Equals 16.
Okay, notice that I got rid of the denominator. Now everything's a little easier.
Yeah.
Still going to add 14. So I still get to that step. The rest is going to proceed the same way. But it was a different way to do the problem. And there is a third way that a lot of people would do. And notice what this is. 4x plus 2 divided by 2. How can I simplify that? All on its own.
2x plus 1?
In other words, divide top and bottom by 2. So I can just make that 2x plus 1. So now I have minus 7 plus 2x plus 1 equals 8. That actually makes the problem a little easier. Fewer steps. So the easiest way to do the problem, this was by far the fewest steps, was noticing that that can be simplified. Now, the problem is if I go back and make that, say, a 3, then it cannot be simplified. In other words, I cannot divide top and bottom evenly by 2. So I wouldn't do it that way.
Okay.
I'm only going to do it the easiest possible way if I can reduce that fraction immediately to whole numbers and get rid of the denominator. All right, guess we need to go on here to the next one. 4, 9. When you are coming up with the equation of a line, what's your standard format? This is the very first one they teach you. Y equal what?
Is this the mx plus b?
Perfect. What is m?
M is
Slope, slope, slope.
slope.
Slope is one of the most important concepts in all of math. It's difficult to see why at this level, but all the way through calculus and beyond, slope is huge.
Yeah.
So remember, m is slope. What is b?
Is that I can't remember right now.
This is called Slope-Intercept format, because B is the y-intercept. In other words, if I told you graph this, where would you start?
3.
And then what would you do? There's 1 point.
Would you go to the 2x?
I would go up 2 and over 1 to the right. To get my slope, connect the two lines. There's the graph of that equation. So slope-intercept format is a great format. If you have an equation in slope-intercept format, you immediately have a starting spot, the y-intercept, and then you just have to find a second point by applying the slope formula. The slope formula, let's talk about that for a moment. That is rise over run. That's what slope is. And that's the way, if you remember it this way, you'll remember it for 10 years. Okay? Now, the rise is the change in the y-coordinates. Here's my two coordinates. That's the x-coordinate of 1 point and the y-coordinate of another. And that's the x-coordinate of 1 point and the y-coordinate of another. So it's the difference in the y-coordinates divided by the difference in the x-coordinates, which ends up translating to this. And this is what they try to get you to memorize, but that's a lot of stuff.
Yeah.
Not the easiest thing to memorize. That's why I say you want to start out memorizing it as rise over run. Because you know that if I say what's the slope of this line, well, you figure out how much up it goes. That's the rise. And you figure out how far over it goes. That's the run. It is the rise divided by the run. That's what slope is. So, they've given us 2 points here. This is the equation. We cannot come up with the equation of the line until we come up with the slope. It's always the first thing you have to kind of figure out is the slope. So plug it in. What's y sub 2?
Y is 2?
Now what is y sub 2? That's how you read these over here. That's the second y-coordinate minus the first y-coordinate divided by the second x-coordinate minus the first x-coordinate. Second y-coordinate.
2.
What's the first y-coordinate?
2.
Divided by the second x-coordinate minus the first x-coordinate. That is a slope of 0.
Yeah.
When you have a slope of 0, you have a horizontal line. And it is a horizontal line that goes, obviously, through the y-coordinate of 2. In other words, there's my horizontal line. And that is defined as y equals 2.
Yeah.
Again, notice that no matter what x is, y is equal to 2. If x is way over here, y is equal to 2. If x is right there, y is equal to 2. If x is over here at plus 10, y is equal to 2. If x is of infinity, y is equal to 2. So that's why horizontal lines are y equals some number, vertical lines are x equals some number. So they said find the equation of the line. We just did, y equal 2. And all we needed was the slope to do it.
Yep.
What is the equation of the x-axis? This line right here. Let me draw it in a different color. The x-axis is that line right there. What is the equation of that horizontal line?
0.
Y equals 0.
Okay.
You need it to be an equation, not a point. It's not the point 0, it's y equals 0. What would be the equation of the y-axis? In other words, this line.
Would that be 0?
Again, it's got to be an equation.
Y equals 0?
It's not a horizontal line, it's a vertical line. What variable would you think it would be?
X equals 0?
All vertical lines are x equals some number. All horizontal lines are y equals some number. If I've got at this point right here 1, and I have a vertical line, then the equation of that is x equal 1. It just so happens that people get quite confused when you draw your vertical line on the y-axis because they want to say y. It's not y equals anything. It's x equals 0. That's the equation of the y-axis. Okay, let's go to the next one, 410. You have a system of equations here. They're both straight lines, notice. In other words, when you have an x and a y and nothing's being squared, that's a straight line. And that's a straight line. X equal 8 minus 3y is also a straight line. So how do I solve this system? If I graphed it, it's where they would intersect. That would be the answer. But if I'm going to solve it algebraically, I got two methods. I can use substitution, I can use elimination. Which one should I use?
Elimination.
Here's the rule. If one of the equations is fully defined for one of the variables, use substitution. This equation right here is fully defined in terms of x. The top one is not. That is not defined in terms of x or y. It's in standard format where x and y are on the left side of the equation. But the bottom one is in x equals something. So if I use substitution, is all I got to do is go up to the first equation, and wherever I see x, I substitute in parentheses 8 minus 3y. So tell me how to write the first equation.
So 2x.
No, I said in parentheses.
Oh.
I'm not writing x, I'm going to write whatever x is equal to. That's why it's called substitution.
Okay, yeah. 2 parentheses 8 minus 3y. And then do you close off the parentheses? And then plus 6y equals 10?
Yeah, notice that is all I did was substituted what x was equal to in the first equation.
Yeah.
But now notice why that's so much better. The first equation is only y's. That means I can solve it for y. I couldn't solve either equation by themselves. But now that I've got one equation and one variable only, I can solve it. What's the next step here? Let's solve it.
Are we trying to get y on its own?
Yep.
So divide by 2.
It's not really a good first step. That
Okay.
gets rid of the 2, but then you got to divide that term by 2 and this term by 2. Well, turns out that that's not so hard because everything's an even number, so I'll go for that. There's always multiple ways to solve an equation. I don't like that as a first step. I like distributing it first and then just combining like terms. In other words, I like getting rid of the parentheses first. So let's do that. Let's get rid of the parentheses first. What am I going to write next? Distribute the 2 to both of these terms.
8 minus 3y?
What's 2 times 8? When I say distribute the 2, that means multiply the 2 to the first term and then multiply the 2 to the second term.
So 16 minus 6y?
Now this 6y is all on its own over here. Now, what's minus 6y plus 6y?
0.
Now I got 16 equals 10. What does that tell me about this system of equations?
That it didn't work?
There's no solution. That's what it says. In other words, whenever you get one number equals a different number, that means there's no solution. There is no value for x and y that satisfy both of these equations. It's basically impossible. Okay? In the same way that, what if I told you the following? X plus y equals 10, and x plus y also equals 9. Is that possible?
No.
No, you're right. If I find the solution to the first one, it is not going to be a solution to the second one. In other words, if I were to combine these two equations, I get 0 equals 1. So I get one number equals a different number, and that means no solution. So there are systems of equations that have no solution. And this is the second one we've encountered. So whoever is making up this material likes these no solution ones.
Yeah.
And A says, describe what happened when you tried to solve the system. Well, we got 16 equals 10, and that means no solution. Draw the graph of the system. If I were to put both of these into y equal mx plus b, I would find that I have two parallel lines. In other words, they both are going to have the same slope, but they're going to have different y-intercepts. Okay? And that kind of makes sense with no solution, right? In other words, the solution to this system of equations is where the two lines intersect. Well,
Yeah.
parallel lines never intersect. I can go to infinity in both directions and they're never going to cross.
Yeah.
And so that's why they ask you in part B to graph the system so that you will see that you're looking at two parallel lines. And they both have the same slope. All parallel lines have the same slope as one another. Their only difference is they're going to have different y-intercepts. In other words, this first one, if I graph it, I'm going to get minus 1/3 x plus 5/3. If I graph the other one, I'm going to get y equals minus 1/3 x plus 8/3. Notice the only two difference between those two equations is the y-intercept. That y-intercept is 8/3. That y-intercept is at 5/3. But both slopes are the same. They're both minus 1/3. The actual graph is going to look something more like this. It's a negative slope. So if I graphed the system of equations, it's going to look like that.
Yep.
With that going through 5/3, that going through 8/3, and the slope on that line is negative 1/3. Okay, so that would be a good description of those two lines. And how does the graph of the system explain what happened with the equations? Make your answer as clear and thorough as possible. And we've already answered that. Parallel lines do not have a solution.
Yep.
All right, I've run over. All right, I'm late for my 4:30, so I got to run. I'll talk to you next time.
All right. Thank you.
You're welcome. Bye-bye.